Hey there, welcome to episode 78 of the Let's Innovate for Vegas audio program. I am your host, Managing Director of the Innovate for Vegas Foundation, Dan Hugo. The Innovate for Vegas Foundation is indeed a Nevada nonprofit, 501c3 public charity, dedicated to enabling, encouraging, elevating communities, enabling and encouraging, if I could read my own historical script, it's not right in front of me, enabling and encouraging ideation, innovation, and implementation to make our communities better. There you go. So we do a lot of stuff, and we are a 501c3 public charity. You'll note I don't really plug that too often during most episodes, but thought I'd mention it now and then to keep that in mind. Episode 78 is being recorded on this, the 13th of August, 2024. The time is a later than usual 3:11 p.m. at the beginning. Today we're going to speak of Polyglot. That is the ability to function with multiple languages. Normally a polyglot is someone who speaks or writes or listens, understands, comprehends, can make use of multiple human languages, but it also just as easily applies and is frequently used in a production by a programming language context, but it can also be used in other contexts, wherever there's a particular language used. Surely if you are a chef and a pastry chef and a, normal chef, is that even correct? There's the language of pastry, and there's the language of pan frying and sous videing and confying, and so on. So there's languages for everything we do. If you speak many of them, or if you can use many of them, whether it's the C programming language or the language of pizza delivery. I don't know, I'm just making that stuff up. Anyway, so today's episode, we're going to speak of the polyglot nature of what we are endeavoring to accomplish with the Innovate for Vegas Foundation. I myself have a academic and professional background in computer engineering, software development. Computer engineering is more, not quite software engineering, it's more about the underlying systems. So I've kind of done both: software architecture, QA, testing, some marketing. So I have a few different language skills in that area, but we can always benefit from learning more. So that's what we'll kind of touch on today. Although I will say we're going to start off with my background, which is programming languages, and go from there. So hopefully wherever you have found this audio program, you are able to see the episode description, which contains the show notes. There's a summary, which I will read. There are some links. There are only 3, and they are, once again, focused on computer programming languages. Nothing we do at the Innovate for Vegas Foundation is exclusively computer programming, but it is my background. So if you speak another language, come on down. Let's do an episode discussing the language of innovation. So let us begin the summary of today's episode. Programming languages. There are many, so many. Sometimes a company or project will pick what people like to call a tech stack with specific programming languages, tools, libraries, modules, and so on, to focus the efforts of their developers. But we are not going that route. That's hard to do when you're not paying people. Also, when you're not shipping commercial software. We don't really have the same goals and release schedules and so on. So yes, once again, I want to emphasize today, because my background is in software, computer programming languages, that's my perspective, but of course the perspective of anyone who participates in civic volunteer projects matters, especially in our approach, which is a whole team. Everybody brings something to the table. Everyone can teach and learn. Let's get started. Today's links, the first 3 are, as usual, our homepage, innovateforvegas.org, which continues to be ugly, but that is quickly bubbling up to the top of my outside, external-facing to-do list. The priority, I've talked about this before, the order of operations episode a few weeks back. Things that are important internally are not as important externally. So our website has not been a high priority destination. It's not serving much in the way of actual innovation. It's just words for the moment. So getting some of our other infrastructure in place and beginning our outreach to other cohorts of civic volunteers is actually a higher priority. So we're working on those tools. It's actually making use of some Polyglot stuff, not only in the computer programming realm, but project management, the use of agile language. We have our Agile for Volunteers effort to help craft a workflow and interaction and communication infrastructure to make the most of volunteer time when it becomes available. So there's a term that comes up, and we'll probably talk about this more when we are focusing a little bit more on putting our Agile for Volunteers into practice. Ubiquitous language is using the same words and the same meanings across a project, across a cohort working on that project, so that people are using the same terms to refer to the same thing. So I may not know completely what in typography, what a point is, what's a pica, what's an M space, what's an N space. If I know those things, if we use those terms consistently, then I'm not going to say things like, oh, that one, it seems like there's a wider, I'm not sure how tall, and I can say, oh, that's 10-point type. I may not know the intricacies or the subtleties, the nuances of 10-point versus 12-point. There's a lot to know about typography, just in general. But if we can be conversant and use the same terminology, then we will not spend so much of our volunteer time on communication. We'll spend it on collaboration. That is to say, we can communicate without miscommunicating. So anyway, innovateforvegas.org. Stop by. I'm not even going to say anything when that new website comes out. Although we do want to use our website as sort of a sandbox or a demo platform of sorts. So as things start to become demoable, if they're useful or not, hopefully they'll make an appearance in some way on our website. So at least check it out. Our GitHub organization on github.com/innovateforvegas. And I will remind anyone new to this program, Innovate for FOR Vegas. No spaces, dashes, dots. Innovate for Vegas is our organization. Innovate for Vegas. Okay, there's one dot. Innovateforvegas.org, O-R-G, for our main website. On our GitHub organization, you'll find our various projects. We are in the process of getting the documentation for Agile for Volunteers. Agile for Volunteers is basically documentation. It's a set of principles based on the original Agile manifesto, some GitHub issue forms, discussion forms, pull request templates, a ubiquitous language glossary, and then there will be some tools to go along with that to make life a little bit easier for people managing or participating in Agile for Volunteers based projects. So you can visit that website. A more visible presentation of these things will come along. Right now there's the usual list of repositories and so on. If you don't know what GitHub is all about, don't worry about it. And Project Act, also on GitHub, our GitHub organization called Project Act. That one does have a hyphen, project hyphen. You might call it a dash, but it's, I don't know. Is that a hyphen or dash? Depends on how many M spaces. Is it an N dash or is it an M dash? Is it a hyphen? Project Act, the Autonomous Cohort Tessellation or Autonomous Cohort Transformation, stands for both. Project Act organization on GitHub recently received the GitHub for Nonprofits tier of services, so we can make use of more free stuff. So thank you, GitHub, for that. Thank you, Microsoft, I suppose. Innovate for Vegas is also a GitHub for Nonprofits beneficiary. Free stuff, free access to things for our pursuits. Everything we do is open source, but they do offer some stuff for private repositories and so on. So pretty cool. The next three links have to do with multiple programming languages. So again, focusing on the software engineering world or computer science or computer programming, coding world. There's a website that Amazon products. Ooh, by the way, I have a new... No. Okay, so that was sort of annoying. So there's a website. Isn't it amazing how such advanced technology is so not useful, so gets in the way? That's why open source is nice. We should be able to tweak these things ourselves. We should be able to make the things that we spend money on work better for us, or work with people who are able to do those things. Certainly no one at Lab 126 would care either way. But I digress. One program in 1,500 variations is a website called 99 Bottles of Beer with hyphens, 99 hyphen or dash, your choice. 99-bottles-of-beer.net. It actually has nothing to do with beer, but only the song. 99 bottles of beer on the wall, 99 bottles of beer, take one down, pass it around, 98. So the purpose of this website, and I've referred to this over the years many times, it's not really an attractive website. It almost looks like a parked website, but they do, and I believe the 1,500 number that they have on their site is incorrect. I think it's many more than that. But when you get there, if you visit, one program in 1,500 variations. So the goal is to have people write some code in their language of choice or other that will render the lyrics of 99 Bottles of Beer on the Wall all the way from 99 to the final. So you have to do a special case at the end. You have to decrement. For bonus points, you can have it decode the number into spoken words, but I think you can get away with just the number. So you're decrementing 99, 98, 97. Really, you should be converting it to 99, right? So 90 for the leading 9, 9 for the trailing 9, etc. But I always found this, especially when I first came upon it, I found it interesting to see literally the differences between programming languages to accomplish exactly the same thing, which is, of course, that is the entire goal of this site. So even though it's old and ugly, who isn't? It is an interesting sort of surface level, like, oh, interesting. I didn't know how PostScript worked. And because you already know what it's trying to accomplish, you can remove, like, what is this code doing? You already know that. How is it doing it? And how is it doing it compared to the language I do know? Maybe you know JavaScript, maybe you know C, maybe you know Lisp. Why not check out how Python or Forth or Perl or Awk or any number, 1,500, take your pick. So I've always referred to this website to get some idea if I hear about a new programming language, so I can say, oh, okay, now I see how that works. Got the T going here. See how this can work. I have 2 Wikipedia links, and the second link's from the first. In fact, the second might link back to the first. There's a list of programming languages, and then they present this list in different ways. So if you visit the list of programming languages page, Wikipedia page, which is linked, or you can search for a list of programming languages. You will see a list of programming languages. The next link I have in there is the categorized list. So list of programming, if I can speak, list of programming languages by type. And there are various ways of describing programming languages. The by type is more nuanced or variable than you would think. So it's not merely compiled and interpreted, it actually intermingles. So for example, I don't know if you can hear those cars as clearly as I can, production by street. So if you look for JavaScript on the list of programming languages by type, and as is common in Wikipedia, they're using underscores. So list underscore of underscore programming underscore languages underscore by underscore type. Or you can just visit the show notes and you can see those links. So if you search for JavaScript, I think it's 13 references. So it includes them in various categories. So it's kind of interesting. You can learn a little bit about imperative versus declarative, functional, procedural, etc., etc. Why so many languages? Well, we're going to get to that right now. So those are the links, only 6. 3 are the usual suspects. The other 3 are all about computer programming languages. There are so many languages. Why? Well, first of all, you can choose a number. I've seen some will view it as like actively used, languages that are familiar or passively used even, like COBOL. COBOL still counts because it still powers a lot of critical infrastructure, even though nobody speaks COBOL anymore. Luckily, it's not a hard language. I've actually tried COBOL. I didn't have anything to do with it, so I wasn't, trying to build a project with it. But I think it would be interesting to implement modern day, not necessarily maybe websites, but implement backend services or something in COBOL, just to see. Who knows? Maybe it could catch on. But COBOL, Fortran is still in use. COBOL is still in use. It may not be actively developed, as in people aren't writing original new programs or code or applications with these. That may not be true with Fortran. That depends. Depends on who you ask. Some people use Fortran for what it was intended for. Formula translation, I believe, is what that stands for mathematical programming. They're not going to go learn R or Julia or Mathematica or what else? There's MATLAB, Math. There's another one. MATLAB, though, is actually pretty cool. But anyway, numerical, symbolic, whatever. There's all kinds of stuff. So there are so many languages. So 250 could be like the number that are in use but are not necessarily prevalent. Could be 2,500, which is a lot more than 1,500 used to write song lyrics. Or maybe it's just one or two that you are most familiar with and use each day. Those are the ones that matter, I suppose. Programming languages are experiments, or they start off that way, to try different approaches to solve different particular challenges. Sometimes it's how can we fit more code in less space? How can we be more expressive? Not everybody wants to learn assembly language or direct machine code, manipulating bit fields and loading registers. That's not fun. Even though you can accomplish pretty much anything you can accomplish with JavaScript, you can write it in assembly language, or which translates directly into machine code. Machine code is I'll get to that in 1 second. Some languages end up being easier to write, but difficult to read. Perl, I would count as one of those. Forth is one of those. There are others. They call them write-only languages. That's arguable. If you're a Perl aficionado, you may find Perl to be a perfectly lovely and very readable language. They are safer regarding memory management, perhaps. Maybe they have better failure modes, more expressive ways to represent memory management of variables, encapsulation of code, various coding practices and paradigms. I mentioned compactness. Maybe it's clarity. Oh no, maybe it's I was gonna say clarity of implementation, but that can vary wildly. Whether you can properly support object-oriented programming with implementation hiding, or whether you are kind of simulating that, etc. The list goes on. And so every different programming language is probably starting off with, and if you look at the language C, which was popular forever, and it's still very much in use today, C was based on algol, algorithm language, I think it is. And it was, I believe, a successor to a language that I think was called B. So obviously C. It's very basic. It's very powerful. It only gets complicated when you realize just how basic and powerful it is. And then you're like, oh my God, I can take out entire global infrastructure by one dereferencing of a zero, null pointer. So yeah, C is still widely used and wildly capable of doing good and bad. So yeah, well, most languages that are in use, so most of those 2,500 or whatever the real number is, it's a big number. They're either derivatives of one or more languages that the creator of a new language is already familiar with, but wants to fix something, address some shortcoming. This is true of spoken languages as well. There's a whole language tree that you can probably find for your personal enjoyment. The evolution of spoken word, written, spoken, Germanic, Latin, language origins, etc. So language language evolves pretty much in similar ways, whether it's for computers or for humans. I'll see if this tea ends up saving the day. So at the end of the day, the code we write in the language or languages of choice turn into machine code that moves bits between memory processing units inside the nowadays wildly powerful CPUs, central processing units, or GPUs, or TPUs, tensor processing, or NPUs, probably neural net processing, or whatever, some Skynet thing. So it's moving bits around between memory processing units, input, output, like persistent storage, drives, hard drives, solid state drives, flash drives, displays, monitors, and so on, audio, blinking lights, motor controllers, who knows, could be anything. So you're really just directing the flow of bits, making decisions on which bits go where. So whatever programming language or whatever spoken word language, pretty much the outcomes are the same. You are trying to evoke a response of some sort in the world, right? If you're only talking to yourself, you can speak whatever language you want. So now my phone is misbehaving. Okay. So it doesn't matter what computer programming languages you speak or spoken word, depends on what you're trying to accomplish. You can speak any language you want, but if everyone else is speaking English, Mandarin, French, then you will probably do better if you learn a little bit of that language so you can interoperate. So when it comes to computers, though, I have some history. And like I said, my background is entirely, well, not entirely. Everybody does more than one thing. But a lot of my historical experience with languages and my profession, academic, personal interests around software engineering, I've come across many computer programming languages in various ways for various reasons. So let us reflect on that briefly. This is not a humble brag. This is just some sort of a context. So early on, I was a self-taught basic programmer. I learned BASIC, the beginner's all-purpose symbolic instruction code, on the Atari 400 and 800 computers that we had when I was in 6th grade at Horizon Elementary School in Glendale, Arizona. I was 11. I was one of the board students. Go learn how the computers work. I've talked about this before in at least one of my other programs that I produce each week. In the 7th grade, I had an opportunity to pair program with a blind college student. Yeah, my voice is not cooperating. It's super humid comparatively here in Vegas, and so I cannot win. So around age 12, given my interest, my proclivities for all things computer, the kind of a friend of a friend said, "Hey, I have a friend who is taking college classes at Grand Canyon Community College in Phoenix, Arizona. She needs help with the interacting with the terminal part. So if you've ever sat at a terminal and programmed on a VAX, learning Pascal, and occasionally a terminal, sometimes a teletype. So I've coded on a teletype with a big giant tractor paper with the green and white stripes. Yep. And then I was self-taught when when I got when we got our Apple IIe personal computer at home, I learned 6502 assembly. That's the microprocessor or CPU, NPU, CPU inside the Apple IIe. So I learned 6502 assembly or machine language. And I started reading books about the Intel 8086. So some initial 8086 architectural learnings. I did not come across a real live Intel part until I was in college. So all through high school, well, I mean, like hands-on, I would use a PC now and then, but yeah, hands-on, making use of Intel parts would come later. Off to college, we had formal computer programming and engineering curriculum, so I learned all about that. It turns out that being self-taught in the computer science field or computer engineering is not unreasonable. So when people say, I didn't need to go to college, I know I'm all self-taught. That is not horrible, but I will touch on some reasons why that's not the whole story. So, but I did take, formally part of my education, part of my engineering degree does include an actual classroom lecture, recitation, engineering, interaction, educational, academic projects in the academic space, our clinic project, all around computers, architecture, software. During the first summer after my freshman year of college, I returned to Phoenix for the summer to recover from a very intense first year. Harvey Mudd College, my alma mater, was a bit of a challenge for everybody. We learned a lot in a very short period of time. So during the summer, I figured, well, why not learn the C programming language? Ironically, they were teaching Pascal in the base, like CS5, they call it Computer Science 5. So I already knew Pascal, so I took the opportunity to learn other stuff in college. But C was always that like, oh, maybe I should try to learn C. And then I really didn't know how to best pursue that. It wasn't until my sophomore year that I became a computer science consultant for the computer science department. And I had access to J. Arthur, the sequent balance, and then later upgraded to a sequence symmetry machine running a multiprocessor Unix variant. I think it was called Ultrix. I always forget this. And I always look it up, so I'm not going to. But if you look up sequent symmetry, the version, it's either Dynix or Ultrix or something like that, but it was Unix, a real Unix, POSIX compliant Unix, I guess, I believe, running on multiple 386, I think it was, processors. It was a pretty cool machine. So I learned all about how that worked. So C and Unix go together like peas and carrots. So if you're going to learn C and you're going to use Unix, you're going to use Unix and you're going to learn C. Or you're going to learn C and use Unix or something like that. So I learned over the summer the C programming language before this using the awful, infamously bad Kerrigan and Ritchie, sometimes called the K&R, book about the C programming language on a IBM PCXT at a company called iPro, something like that. Yeah, so I learned C for a summer job. Of course, you never stop learning C or any programming language, so my learning began. Designed and built an orthogonal microcoded CPU with my lab partner Bill in our microprocessors class during my senior year. That was a really, really interesting class, one of the most interesting, I think. There was a cookbook design. So this was a hands-on lab experience. We had breadboards. We had all sorts of components, dual inline package, breadboard compatible, friendly. We had PALs. We had EPROMs, erasable programmable read-only memory. We had, did I say PALs? We had programmable array logic parts. We had ROMs. Those were not as useful. Not for development. We had arithmetic logic units. We had registers. We had the whole nine. There was one. What else did we have? We had PALs, microstore, and ROM. There was some other part. AOU register. Anyway, so Bill and I would go to a Thai restaurant called Salam Luang. So we took the cookbook thing there, and the professor, Dusan Petronovich from Montenegro, visiting professor, very interesting character. He said, you can either build the cookbook and, that'll be fine, or you can try your own. So we were sitting there having our Thai food, and we said, hey, we should try to do something more interesting than this. What the cookbook suggested was very state machine based. And we said, what if we built a micro store and we had micro instructions and we attached all these registers and ALUs and everything to a common bus, and we could execute the microcode instructions to control what the chips were doing on the bus and moving things around. So we had a micro store in the EPROM, so erasable ROM, which was useful because we could then erase them with some ultraviolet light, which we did many times during our development cycle. We used a PAL to route our signals, so the micro store of microcode instructions would route through this PAL, so the PAL would route the signals to the different parts on the bus. We could attach registers. We had our arithmetic logic unit. We had other components. So we designed the whole thing so that you could attach arbitrary components to this bus and move bits around between them according to the instructions in our micro store. So each micro instruction had 4 phases. So we had a manual toggle, so we could actually step through each of the 4 phases of a micro store micro instruction. You could literally watch the bus changing. You could watch bits going onto the bus. You could watch bits being pulled into the selected register or the selected ALU, and so on. So it was completely fascinating. It was a tremendous learning experience, let's put it that way. That was in the first semester, and then that was a 1 semester class. We took advanced microprocessors in the second semester, Bill and I together. We learned all about the 68HC11 microcontroller. We wire wrapped a computer of our own design. Bill got extra credit for machining a gyroscope with some help from Ed Stubblefield, but that's a different story. A spinning gyroscope. Today you would, of course, use a 9 degree of freedom micro machine gyro. But so we built a balancing robot, inverted pendulum robot with a completely home-built embedded computer. Talk about a learning experience again. And then, but before that, in my junior year, I was on a clinic team for a company called ESL, a division of TRW. And they were building a demonstration for the DRO1 digital receiver super chip. So it's kind of a software-defined radio receiver. So we built a new bus board for a Mac. That was their desire. So we built this new bus board, having no experience doing this. We completely designed and had built a new bus board in the first semester of our 1-year-long project, or 2-semester-long project. The second semester was spent debugging, developing some software, some LabVIEW integration, and so on. So yeah, a lot of learning. There was another microcontroller, CPU. Anyway, the college was an interesting time for picking this stuff up. And this again is why, on the one hand, self-taught, right? We went and learned how to wire wrap a computer. That wasn't part of our curriculum. But in the context of academic pursuits, it sets up a different sort of mindset if you're learning something new. So this is something that Harvey Mudd was, I can't speak to whether they still are, but known for learning how to learn, being immersed in an environment that was learn friendly. So being self-taught sometimes means you just go off on your own and try to figure it out. And if you've ever tried to learn a speaking language on your own without speaking to someone else who speaks that language, good luck with that. In the real world, the fundamentals of all this were implanted in my brain, my mind. So learning a new language or new methodology is not necessarily easy, but neither is it a mystery. So once you know C, you can learn JavaScript. Once you know, pick another thing. Once you know any sort of declarative language, once you know SQL, once you know how databases work, you can learn a new way. So once you kind of have a feeling, you can apply all these things you've learned over the years in your academic setting and before your personal interests. So it all kind of comes together. And I have to say, this is what people who are polyglots in the spoken language or the human language world will say something similar. Once you learn your second language, learning the third one is easier, and the fourth one easier still. The vocabulary can be a little bit tricky. You might find yourself confusing words, and if you speak multiple programming languages, you'll find yourself saying, is that a semicolon that goes there, or does this use commas, or is white space significant, or whatever? So you might jumble them up a little bit if you move between them frequently, but that goes away after a few iterations. You go, oh, that's right. Okay, I'm programming in JavaScript right now. Now I'm doing SQL. Now I'm doing Python. Now I'm doing C. I myself have come across C++, which is not C. So whenever you see in a job description, C/C++, like they're the same thing. Not really. SQL, Perl, Python 4th, more assembly language for the 8051 and the PowerPC, awk of all things, which is a classic and a really good tool to have in your pocket. Newton script when I worked in the Newton group at Apple, where I also was working on the C++ developers toolkit, but I've used C++ in a few different contexts. I wouldn't call myself an expert C++ programmer. I don't know if anyone would. JavaScript a little bit. I was working at Netscape, so we use JavaScript there, and of course you kind of have to deal with it. Do I sound like a JavaScript fan? Some Java, some C#, maybe a few more. So in your travels, if you're going to work in the technology field, you're going to pick up, you're going to encounter, you're going to experience, you're going to read about, you're going to have to debug or use, you're going to have to integrate with different technologies, different libraries, modules, services, etc. So having some familiarity will just come in handy. For a variety of reasons, my personal stack has for many years been Linux, PostgreSQL, Python, and then whatever else. I like Python because it's really easy to play with. It's easy to try things out. It's easy to experiment with. And there is a metric ton of libraries, modules, samples, examples, integrations. Python has a lot of gee whiz. Hey, that's cool. Wow, that is a really useful feature or thing. So the way the language operates has only been getting more interesting over the years. I've been using Python to develop real things since 2004 or so. I didn't include PHP on here because I am not a fan of PHP, nor should you be. But I did a lot of stuff with PHP as well, which, if I'm not mistaken, stood for personal homepage, but I don't know if that's still true. What is a stack? Anyway, I said stack, my own personal stack, but what is a stack? I think I even referred to tech stack somewhere in our introduction. What is a stack? Well, first of all, we do not have a tech stack, as I mentioned. Our foundation is not a software or products company, so we do not need to dictate requirements to civic volunteers. We don't say, you must use this, you must use that. Although any particular project will probably gravitate towards tools that are more familiar to the people working on them. There are some better choices to make in that regard, as the saying goes, pick languages that you can hire for. The best language might be Lisp, but the number of programmers that are on the job market who can program in Lisp, much smaller. So if you're trying to ship a product, that's very different than trying to work on civic volunteer projects. Now, it's really difficult to tell someone who is willing to contribute their time as a volunteer, like, oh, we're not interested in your Lisp programming skills because we are using JavaScript. What you could say, and what our take is like, okay, well, build some stuff in Lisp and make it work with the other stuff that works in JavaScript, and everybody will learn something. A non-trivial job, and in fact life skill, is the ability to interoperate, integrate, and basically work across those communication boundaries, whether it's Lisp to JavaScript or English to Chinese or Chinese to French or whatever, right? So this is true with programming languages and human languages. If you can, in some way, learn how to speak to someone else or write code that can quote-unquote speak to some other code across literally language boundaries, you will learn something. You will have learned something. When it comes to open source volunteer projects, there is value not only in including the time, effort, and expertise of those willing to contribute those, but also to make use of other works which may be using other languages, other technologies, stacked in other ways to integrate and interoperate with the rest of the world. There's often more than one way to do it. Sometimes others have already blazed useful trails. So I still haven't said what stacks are. Stacks are literally the pieces that are stacked together to handle different needs of a particular application focus. So most of the time today you will hear a stack as it refers to building a website. And it's funny to me that most people will say, oh, the internet is dead, the web is dead, everything is on Google and Facebook and all that. Yet, notwithstanding the layoffs of modernity, there's no shortage of web frameworks, of tech stacks for web development, for developing front end, so the view that you see in a web browser or a native application, or being able to build for both, a database layer, a NoSQL layer, if you're going to use Mongo or Couch or Cassandra, or the list goes on. Maybe you're a MySQL fan, maybe you love PostgreSQL like I do. That list goes on. Maybe you like Python or Node if you're a JavaScript fan. Maybe you like Rust or Go. So you can, but what if the best tool for the job is not necessarily Go this time? Maybe it's Julia, or maybe we're going to write some logic programming. So we want to use Prolog. You laugh, but who knows? You might want to use Prolog. So if you can interoperate between these different things, then you might have multiple stacks that you can stack together. And sometimes the code or service or thing you need to use is using a different stack than yours. So being able to move comfortably, if not freely, between these different things can come in handy. So that's why we don't dictate a particular tech stack, or we don't say, oh, you must learn or you must know JavaScript or Python. Like, those are two good languages to know, but there are many other good languages to know, good practices to know, etc. And then don't forget the other stacks. So I've been focusing on computer programming. It's my background. So this is computer programming side. I've gone down the litany of technologies. And do I need to store data and retrieve it? Okay, I need a database. Do I need to do something with the data? Okay, I need a business logic layer. Am I interacting with users? Still need that business logic layer. Do I need people to be able to interact with my thing? Okay, I need a presentation layer of some sort. The other stacks revolve around being a visual artist or an audio creator or a video editor, a storyteller, a project manager, and the list goes on. You may use completely different language. Sometimes these are called domain-specific languages, DSL, a particular application of a collection of terms that mean something very specific in the domain, sometimes referred to as jargon. It may be just as useful, sometimes even critical to a particular focus area as the programming languages I was just describing are to the underlying computer hardware. So if you are an audio editor and you use certain, and some will apply to video editing as well, in points, out points, sampling rates, tracks, right? These have particular meanings that don't, like a track has different meanings to different domains. If you are driving the big trains, a track is one thing. If you're editing video or audio, a track is another thing. If you're trying to keep track of something, you may be a private investigator. So the different terms might have different meanings in different contexts, and it's important to know what your context is when you're talking to other people. This in itself is a job skill or a life skill, to be able to communicate with people across your domains. If you've ever had to maybe go have your car fixed, repaired, or you're trying to have a home built, or you're trying to have someone make a website for you, or you're trying to make a website for someone else, if you're not speaking the same language, it can be very tricky. So learning how to be a polyglot, learning how to adapt to the interface, the interaction between languages, between the intent of the languages, right? The person you're speaking to, if they're not speaking the same language as you, they want to accomplish something and you want to help them. And the only thing getting in the way is that language or languages. So I've only had glancing bits of experience in various related areas when it comes to project development. Those projects will have a user experience, they'll have a user interface, they'll have maybe internationalization and localization, they'll have workflows that are part of the user experience. They may have assets like video, audio, icons. There's all kinds of stuff that I've only barely touched on. And so when you really find the good stuff, and Apple was famously hyper-focused on user experience, and they had the application style guide requirements. So if you were going to make an Apple Macintosh application, it had to look a certain way. They had a whole bunch of code around that to implement it, so that as a programmer, you would call on the Apple code to do that. So being able to speak the language of user experience on an Apple Macintosh platform became a way for a programmer to bridge the gap to someone who is not a programmer, but to be able to accomplish the thing that they're trying to accomplish. So it can be very nuanced and very powerful to be a polyglot, especially if there are tools and methods and best practices and practice, as in you do it a few times more and more and you become adept. And before you know it, you're building cool things, whether it's programming or food or visual or audio or projects in general. Project management is a whole special thing that is very important. It is often written off by those, and QA, same thing. Like, oh, somebody can just do project management, or somebody can just test on the way out. No, you have things to learn, and the language to do so is maybe not in your library of skills. So polyglot it is. For all the things I would like to accomplish, I have other things to learn, and that's probably true for you too. Especially when it comes to design language for user interfaces and user experience. I know how to do audio, hopefully. A video I have done a little bit when I worked at True Vision. I have a small amount of experience with. The interesting thing about a civic volunteer cohort made up of diverse contributors, each person will have their own mix of experiences and interests, where we can share experiences and pursue our interests, and then vice versa. So someone who is a visual designer, user experience designer, someone who's a program manager, project manager, someone who's a QA person, a tester. I started my career in QA as a tester, so I use that as a term of solidarity, not insult, not diminishing. In fact, and I think I may have mentioned this before, someone right here in Vegas has a software development company, and he once said to me, "Isn't QA supposed to be adversarial with the engineering development team?" And I said, "Oh my, you're all on the same side." So QA, project management, program management, marketing, storytelling, like what is the reason? Start with why, as Simon Sinek might say. So if you interact with people with different backgrounds, different levels of experience, and you do so because you want to, not because you have a job and it's your job to deal with. There's a famous tension between engineering, sales, and marketing at tech companies. But when you're not a tech company, suddenly you may find that, we can just cooperate. Wouldn't it save a lot of time if we're not trying to build our own little empires? We can learn each other's languages and learn each other's workflows, I guess you could say, so that we can actually accomplish things. I don't want to waste my volunteer time arguing over subtle meanings and nuance. So what if we just all speak a similar language or learn how to interoperate? So polyglot really is a good idea. So if you have the volunteer cohort with, I may know more about one thing and someone else may know more about a different thing, and we may both say, I'd like to learn about that thing that you know more than me about, and let the learning begin. Likely we all learn a thing or two from each other and from the projects we pursue. That would be cool, wouldn't it? Putting what we know to use and learning what we need to learn to do what we want to do. These are two great tastes that go great together. And when we can apply these notions to collaborative efforts, each person can win, the cohort can win, and the people who use our stuff and benefit from it can win as well. And that is why we want to enable and encourage ideation, innovation, and implementation. That means people collaborating across their language boundaries, across their experience levels, across their particular interest areas. When you put all those things together, what is it? The whole is greater than the sum of its parts. When people are learning along the way, you may find yourself, I could contribute an hour or two a week, and maybe you'll find, that was interesting. I learned how to work with Figma, or I learned how to edit video with DaVinci. I can't remember what it's called. DaVinci video editing. I learned how to use Audacity. I learned how to do, machine language model training, whatever it is, I learned how to tell a good story so we can describe our product to people. What do we work on? Try describing what you work on to someone. See what they say. Do they ask questions, or do they just say, wow, that sounds cool? Do they say, what do you mean? I don't understand that. Those are two different stories, right? So if you can be a polyglot and you can learn from others in a context where we're not shipping software. We do eventually ship software, but that's not the goal. We're not making money. We're a nonprofit. The goal is community elevation, so we can do so wisely, not competitively, not necessarily, and see where things go. And along the way, like I said, hopefully everybody learns a thing or two, and these are actual job and life skills that will pay off many times over in the future. that's where I'm going to leave it. Don't forget, we're a nonprofit. We're a Nevada nonprofit corporation. We have been since June 16th, 2022. So we're just over 2 years old. We got our 501c3 determination as a public charity, tax-exempt organization in October of 2022, retroactive to our formation date, so June 2022. So we're 2 years and just about 2 months into being a 501c3 public charity. All of our projects are about elevation. We're not shipping for profit and whatnot. On the other hand, we do have a value proposition that will hopefully bring some sort of, I cannot speak today, obviously, that will bring some sort of return on investment of the civic volunteer time, effort, and expertise that people bring to the projects, bring to the table. So that something, what's in it for me, you might say? Well, something. We start with full attribution, so there will never be a unknown contributor, unless they want to be, right? You can opt out. But testing, offering suggestions, feature requests, you should be a part of the big picture. We're not trying to build personal brands here. We're trying to build a cohort of successful contributors. And for giving your time, you deserve credit, you deserve attribution, you deserve some degree of celebration even. So it may be something to include in our portfolio or get a job from it or notoriety, fame, eventually. Perhaps you want to participate in the rollout of our labs projects where we deploy actual projects for people to really use, and they may be an arm's length monetizable for-profit entity, maybe for public good, maybe for just normal plain old profit. So maybe you start off as a open source or civic volunteer developer of whatever it is, software, hardware, visualization, marketing, storytelling, QA, etc. And you become a compensated contributor to the for-profit side, the deployment. And if you want examples of that, you can look at the Linux kernel, you can look at WordPress. Surely there are there's a tool like Penpot, PENPOT. Penpot is a open source version. It's a competitor to Figma. So you can do a lot of visual design, user experience process with completely free tools. So the software people working on that have to work with real designers. So the languages that they speak are important. So they have to be able to interoperate so that one can deliver for the other and vice versa. And the list goes on. So not everything is software. Don't forget that. Anything you use in the world that is worth using probably has a little bit of software and a lot of other skill sets and contributions that make it worth using and useful and worthwhile. So that's enough of my ad-libbing at the end here. Don't forget innovateforvegas.org. Innovate, F-O-R, Vegas, no spaces. Innovateforvegas.org is our homepage. From there, you will find links to other things that we're working on, and you'll find a link to the current episode of the podcast that needs to be updated so that it's always the current episode, but we need to have all of our episodes accessible through our homepage, and the list goes on. So more things coming, never more time to do them. It's a lot easier if you speak multiple languages, and that is where we will leave today. Thanks for listening.